So first, let's discuss chapter five. Sorry, chapter five. So the nano world or nano. It's all about nanoscience and nanotechnology, a technology in a small scale. All right. So the learning outcomes for this chapter, one is to define the major potential and realize the impact of nanotechnology in society, to analyze nanotechnology through the conceptual STS lenses, and lastly, to examine the costs and benefits to society of nanotechnology. I'm sure everyone is so uh, familiar with nanotechnology because you are using gadgets such as iPhone, LED TV, laptop, no? So those are examples of nanotechnology in a small scale, no? So in the past, you are using um, uh, a monitor that has what has a big back, no? Because of nanotechnology, it became thinner, right? So that's a good example of nanotechnology. A good example of this also is your cell phone, no? Dati ang cellphone napakalaki, but today became thinner, no? That's a good example of nanotechnology that later on I'll be discussing it with you. So why nano? What is nano? When we talk about nano, it refers to a unit meaning 1 billion or 10 raised to negative 9. So for example, a nanometer is 1 billion of a meter. Hence, nano expresses a very tiny amount or size. So it can be compared to a size of a DNA. No, for example, kukuha na kayo ng DNA for example, blood. So sa blood, may cell. Sa cell, sa nucleus nun, may DNA. Alam mo naman, di ba? Uh, um, in a cell, there is nucleus which controls everything. So inside the cell, there is DNA. So ganun kaliit yung technology ng nano in a small scale. So the human being can now manipulate a materials in a nanoscale level. So, super high-tech, kumbaga, di ba? Kaya nga, mas manipis yung cellphone, mas manipis yung TV, mas high-tech because of this one, because of this nano technology, no? Makikita mo dun sa figure, as you can see on the figure, mas maliit pa siya sa bacteria. Pero of course, mas malaki siya sa atom. No? Kung makikita mo yung grain of salt, nakita mo yung grain of salt? Yes, of course, no? So, next is bacteria. Then, next is a DNA. So, kung makikita mo, andun yung gap ng technology. Pakahirap nun. You manipulate a material. It can be a solid. It can be a liquid. No, it can be a gas. You can manipulate a matter in this scale. Di ba? Of course, in medical, nagagawa na nila yan, no? Yan, kinukuha na ka ng dugo, then they can have it as their as a mean of diagnosing a disease, or if there's a malfunction in your body, di ba, kuha na ka ng dugo, sa dugo may cell, no? Then in the or tissue, kumukuha ng tissue sa'yo para makita in cell there's DNA. So in that particular scale, they can diagnose if you have a disease or not, no? So that is a good example of manipulating things in a nanoscale when it comes to um, medical factors, no? But today, yeah, no, they can now manipulate things like in technology, no, particularly intangible objects in gadgets, no. Next, let's talk about nanoscience and nanotechnology. When we talk about nanoscience, it is the study. It's all about knowledge. No? Diba? Uh, I already we already studied what is science last midterm period. It's all about a systematic body of knowledge based on careful observation and experimentation. So, lagyan mo lang ng nano yun. It is a systematic study in a small scale of body of knowledge based on your careful observation and experimentation. So, it's all about knowledge in a small scale. That is nanoscience. When we talk about nanotechnology, it's all about application of that particular knowledge. For example, alam niyo yung bike? Of course, alam niyo yung bike, right? No? Alam niyo yung rim. Sa bike, may rim. Yung nasa gulong. Kung makikita mo, may maninipis na rayos. Tawag po doon rayos, no? Nakita mo, it can withstand with the bike and with the weight of the bike, kahit dalawa pa kayo, tatlo, kaya. Because of that particular nanotechnology in the rayos. Nakuha mo? Ganon katindi. So even before, meron palang ganong meron palang ganong technology. Yes, meron. But now we can also materials in relation to information and communications technology. We can do that, no? With this technology, nanotechnology. Okay, later on, mas maiintindihan niyo yung sinasabi ko. So, kung makikita mo itong we have this one. Again, when we talk about nanoscience, it's all about the knowledge in a small scale. When we talk about nanotechnology, it's all about application of that particular knowledge in a small scale in different fields. It can be in chemistry, biology, environmental science, no? Engineering, pwede po yun. Yung mga ini-spray lang, that is a technology in nanoscale. So, in chemistry yun, related to chemistry. Engineering, pag sinabi mo nung kasi engineering, pwedeng in computer engineering, pwedeng in electrical engineering, no? So, those are applications of nanotechnology today. So, guys, if you have question, just comment in the chat box, or you can turn on your mic, no, to ask me directly. So as you can see, the human hair on the figure, no, as you can see, yung nanofiber, mas maliit pa siya. Ganon katindi, no? Galing, no? Manipulate nila yung things with this scale. Of course, using another technology such as microscope, no, and other related things. Okay, so one of the examples of nanotechnology products was used during the pre-modern era was medieval stained glass window. So in this particular window, there there has been already a nanotechnology um, invention, no? Hindi lang nila alam 'yun. No, hindi lang alam nila 'yun, pero ginagagawa na pala nila. They can manipulate things in a nanoscale, such as this medieval stained glass, kaya nagkakaroon yun ng color, no? Because of some elements or chemicals inside of it, no, in a nanoscale. So, and this one medieval stained glass window is one of the first, no, nanotechnologies in the world, no, and discovered. Guys, mabilis lang to, no. Actually, baka nga makatatlong chapters tayo, no. Mahinig lang kayo para mas maintindihan niyo, no. So, first, let's talk about biomaterials, no. So, these are the applications of nanoscience, which refers to nanotechnology. So, these are the different applications of nanotechnology. So, first, we have biomaterials. Bio means life. Materials, meaning it's a state of matter. These biomaterials are being used in healthcare, such as imaging tools to diagnose diseases, to treat diseases. Ito nga yung sinasabi ko kanina, no? Ito yung sinasabi ko na they can manipulate things in medical field, no? They can diagnose cancer. Di ba, cancer cell? So, kukuha sila ng, they, they already been doing that, no? In terms of in the medical field, no? HIV, cancer, and other diseases, no? This is a good example of uh, biomaterials, no? Um, they are using tools to diagnose those diseases and also to treat those illnesses. Yung COVID-19, no? COVID-19. Ginamitan nila ng ng biomaterial tools, no, to detect that particular disease. COVID-19 is a disease, no? Two, ceramics. So, an example of this is nanoceramics paint coating. This is being used as a car paint coating to provide protection and shield. So, kung makikita mo yung chemical na yon, of course, there's manipulation. There's already manipulation and there's already added elements in that particular chemical that can provide strong protection and keeps the paint of the car look shiny. Kung makikita mo, sobrang kinis nun because of the nanotechnology in the coating chemicals, no? Kaya sobrang niyan. Kasi sobrang liit, 'di ba? So, sobrang liit ng chemical niya. Pinoprotection na niya yung yung coating ng car. Hindi yan basta-basta hindi yan basta-basta dudumi. Hindi yan basta-basta mawawala yung pagka-shiny niya because of that chemical in a nanoscale that protects the car. Next, metals. Ito nga yung sinasabi ko sa inyo, no? Di ba sa task nyo, sa task 2, you are asked to do a paper tower using 10 papers only, no, and 20 inches tape. Guys, kung makikita nyo, ito yung papel, no? Pwede nyo akong click, ha? Kaya tingnan nyo to. Pag sabi kasi sa nanotechnology, sa nano theory, pag ang bagay ay nakaroll into, nakaroll. Kunwari, eto, paper sheet to. Okay, so yan, tutupiin ko lang. It's not rolled, tutupi ko. So ngayon, pagka tinupi ko yung bagay, ayan siya, nakatupi lang. Hindi siya nakaroll, o yan. Tingnan mo, pipitikin ko. Ito mo. Yung mayupi. Subukan natin i-roll. Sabi kasi pagka ang bagay naka-roll, mas mas tumitibay. Sige. Tignan natin. So yan tignan natin kung totoo. Yan na. Nag-roll ko po Maganda kasi ito sa live no? Mas maganda kasi sa live. Ay, sa face-to-face. Actually, groupings talaga yan. Pero we cannot do it groupings. Yan. Tingnan natin. Pipitikin ko. Nakaroll na siya, ha? Nakita mo? So, mas matibay siya pag ang bagay ay naka-roll. Lalo na in a nanoscale. No? So, kung makikita mo, ang bagay mas matigas, mas strong pag ito ay nakarolyo. So, kung makikita mo yung metals, sa badminton racket, napakanipis niyan. Pero, may nanotechnology in that particular metal kasi nakaroll siya inside in a nanoscale. Yung rayos na sabi ko sa bike, sa motor. Di ba, nakaganon sa gulong, May parang mga string na napaka ang tawag po doon, Raisa, girls, ha? So yun, kahit napakabigat, kayang i-carry because of that nanotechnology. Another one, pag gumagawa ng bahay, di ba yung mga nilalagay ng bakal? Pero ang forma, di ba, nakarolyo? Pako, paano nakaka-penetrate yun ng wall? Kasi nga, naka-roll yung metal elements. Nakuha nyo? Nakuha? Pako nakakabutas ng wall. Because of it's design. No? Kasi nga naka-roll yung elements, yung carbon atoms na later on. No? Kung makikita mo, string. Sige, string. Sabi natin string. Sa string kasi, sinasabi ko, yung sobrang matatagas, makakapal na, hindi naman makakapal na string. Matitibay na string. Kahit tatakan mo, di ba? Pag nag-tag of war kayo. Kasi nga, yung string na yon, sa isang string na yon, may 10 string na nakarolyo. Then sa bawat isang string dun sa 10 nakarolyo, may tigs na 10 pa. Ganun yung nanotechnology. No? Kung makikita mo ito, as you can see on the figure, the first figure is single-walled carbon nanotubes. No? Isang rolyo lang siya. Pero when we talk about multi-walled carbon nanotubes, makikita mo, in a nanoscale yan. Ha? So in a nanoscale, nakarolyo siya ng pabilog. So mas matibay. Diba? Mas matibay. So ganun yung mga pako, yung mga rayos. Sabihin mo, string po to, string. Diba? Pagka nagtatahi ka, gumamit ka ng sinulid. Di ba sa sinulid, yung isang sinulid is composed of 10 sinulids pa. Ganun din yung sasabi ko. No? Kung makikita mo yung mga lubid sa barko, di ba, ang kakapal, pero sobrang tibay. Makikita mo sa tower, sa bridges. Di ba, sa bridges may mga parang bakal na nakatali, parang bakal. Yung bakal kasi na yun is made of multi-bakals o metals pa. Then dun sa bawat isang metals, marami ring metals inside that particular metal. So ganito po yun. Kung makikita mo, sa multi-walled carbon nanotubes. Kaya sobrang tibay niya, no? So makikita mo in naked eyes, no? Yung rayos, kala mo isang lang siya. Isang diretso. No. That rayos is composed of different metals, no? Different carbon nanotubes inside of it. Kaya sobrang tibay. So we have this one, di ba? The arrangement of the structure of materials at the nanoscale can change its strength. Guys, kung makikita mo to, makikita mo yung di ba? Makikita mo yung pencil. Pag gumagamit ka ng pencil, ang niya kasi, ang structure niya, sheet type lang siya. Parang plain paper sheet. Ganun ang niya. Ang arrangement ng carbon atoms niya. Carbon atom is an element, guys, basic chemistry. So, naka-arrange siya in 2 sheets. So, pagka sinulat mo, di ba nalalagas? Kasi nga, yung structure ng element in a material, palapag lang siya. Nakuha niyo po ba? Pero pagka naka-roll siya, like diamond that can cut steel, matibay. Nakuha niyo? So, if you manipulate things, it can change its strength. Kaya nga sasabi ko, gumawa kayo ng tower, you can see, di ba yung Eiffel Tower? Eiffel Tower is composed of a rolled materials. Kung makikita mo, di ba? May mga flat, of course, of its design. But, in that particular structure, may mga role to support that particular Eiffel Tower, di ba? Next, polymers, no? This has been used to enhance and strengthen computer chips, especially its design. Kasi nga, di ba, sa first generation computer, napakalaki. Yung first generation computer, first ha, 200 square meters ang ang sinasakop, no? First generation computer. But today, they can manipulate things in a nanoscale. Kaya nga yung mga cellphone yun, napakanipis. Yung laptop natin, napakanipis. Etong monitor ng laptop ko, nakalagay nano edge display. Makikita mo nano edge daw. So maninipis. Manipis yung edge na. Kasi nga again, they can manipulate things in a nanoscale, which can be compared to a size of a DNA. We have two commercial applications of nanotechnology. One, we have sunscreens. So these sunscreens provide protection from harmful UV rays. No? This has been possible through the use of nano-sized zinc oxide that reflects and absorbs UV rays and made it ultraviolet resistant. So this particular chemical, this particular sunscreen has a nano-sized zinc oxide that protect your skin from harmful UV rays of the sun. So ang galing, di ba? Chemical engineers did this, no? Sila po ang nag-invento nito, yung mga chemical engineers, no? Chemical scientists, yan na yun, chemical scientists. Mas mataas. Chemical scientists. So, sila yung naka-invento ng particular type of this creation, which help your skin to be protected from the harmful effect of UV ray. Kasi nga, syempre, pagka wala kang ganyan, tapos sobrang tagal mo sa araw, it can cause what? It can cause a burn, diba? Kaya nga, minsan, di ba, pag naglaro kayo, bata pa kayo, sabihin natin mga elementary level, no? Basketball ka, hindi covered court, okay lang, no? Tapos pag sunog yung skin mo, hindi maganda yon, no? Okay lang yan. Sabi mo, okay lang yun. Ito babalik naman ako. Pero hindi maganda yan. No? Kasi nga, nababurn yung skin mo and it might affect your health. Di ba? Last one is self-cleaning window. No? So, as you can see on the on the left side of this window, it's an ordinary window. It's not a self-cleaning window. Kasi on the right side, no, you can see the self-cleaning window, which of course, break down the dirt and stain repellent fibers that can wash away by rain. Kasi nga, sa sobrang smooth niya, in a nanoscale, it has also chemical on it, hindi lumulubog ng certain chemical. Kasi di ba, for example, eto na lang, let's make it simple. Kapag ang bagay, may mga butas-butas, hindi siya, tingin mo ba, pag kinapitan nyo ng another thing, like such as water or it can be solid or it can be a liquid, dudulas ba siya? Hindi, kasi nga rough siya. If something is so smooth, another things will slip away, di ba? So sa sobrang smooth niya, using nanotechnology, dumudulas na lang yung dirt and yung tubig, making it self-cleaning window. Saan po ba ginagamit ang self-cleaning window? Of course, ginagamit nga ito para magkaroon ng self-cleaning window. Pero saan usually ito nakikita? Usually po nakikita ang self-cleaning window sa mga matataas na buildings. Sa building. Kasi siyempre, for example, 100 floors, sabi natin, 100 floors. Tingnan mo, ang gastos nun, papalinis mo pa yung labas ng window mo, di ba? Pero if you have this, hindi mo na kailangan linisan. Kaya nga na-invento to para sa mga building na matataas. Why? Number one, sobrang hirap linisin nun. Pwedeng mamatay yung tao, di ba? Kasi building yun, napakataas. Two, it costs a lot. Mag-hire ka ng tao para linisin lang yung salamin. Di ba? But if you buy this one, lifetime na yan. No? Mas maganda to kung ngari, magpapa-third floor kayo or second floor. Gusto mo yung harap ng bahay mo, windows lang. Maganda yun, di ba? Architectural design or yung kita yung mga yung hagdanan ng bahay nyo, papanik, third floor. So, magandang gamitin ng self-cleaning window para hindi mo na siya lilinisin. Siyempre, mas mahal. No? Mas mahal. Pero, makikita mo naman yung makikita mo naman yung uh, benefit, di ba? So, that ends the nanotechnology part. Actually, konti lang yung topics dito. Mabilis lang, no?